So I want to take today to kind of wrap up what we've been talking about with piecewise functions. So we're going to look at a couple examples first of graphing. So remember, since this is a video, you can stop, pause, rewind, rewatch, however many times you need to, slow down, copy, whatever you need to, okay? So the first thing we want to do is graph this function. We have the piecewise function defined by f of x, which is equal to x plus 5 when x is less than negative 2, and x squared plus 2x plus 3 when x is greater than or equal to negative 2. Now, I'm going to show you how to do this using sort of a table method, which we talked about the very first day that we looked at this and kind of talked about a little bit more earlier yesterday. So what I'm going to look at is negative 2 is where my graph is going to be starting in either one of these cases. So I'm going to figure out the value of x plus 5 for negative 2. So I'm going to plug in when x is equal to negative 2, I'm going to do negative 2 plus 5, which gives me 3. That means my starting point is going to be the ordered pair negative 2, 3. Now, because for this particular piece, it says that the graph is for x values less than negative 2, I'm going to pick one or two more that are less than negative 2. So negative 3 is less than negative 2. If I do negative 3 plus 5, I get 2. So that means I now have the point negative 3, positive 2. And we could keep going with this. I'm not going to do another one because I know that x plus 5 is linear and it's going to keep going in a straight line. But if you weren't sure what it was going to do, then you should go ahead and pick another one. Do x equals negative 4 and see what you're going to get to. So I'm going to graph this one first. At the value negative 2, 3, that ordered pair, I'm going to have an open circle. And I know that again because it is less than negative 2, not less than or equal to. So negative 2, 3 is this point here with an open circle. The next point that I had was negative 3, positive 2. That's going to be here. This is a line with a constant slope, so it's going to keep going this way. So there's the first piece of my graph. Now the second one is a quadratic. We haven't done any that looked like this. The idea is going to be no different. I'm going to pick my starting point, which was negative 2, and then I'm going to pick 2 points to the right. If it's a function you don't recognize, pick 2 points. I promise it'll help you out the most. So let's look at x squared plus 2x plus 3. When x is equal to negative 2, because that's our starting point, I get negative 2 squared plus 2 times negative 2 plus 3. That's going to be 4 minus 4 plus 3. So that means that this is equal to 3. Positive 2, positive 3 is my first ordered pair. Now I'm going to go to the right. I'm going to do x equals negative 1. This time I'm going to the right because I want values that are bigger than negative 2. So I'm going to do the exact same thing. When I plug this in, I get negative 1 squared plus 2 times negative 1 plus 3. That's 1 minus 2 plus 3. 1 minus 2 is, whoops, I wrote 1. 1 minus 2 is negative 1. Negative 1 plus 3 is 2. So my next ordered pair was negative 1, 2. And I'm going to do one more just to be safe since maybe you don't know right away what a parabola is supposed to look like when I graph it. So if I do x is equal to 0, I get 0 squared plus 2 times 0 plus 3. Well, that's just going to be 3. So 0, 3 is the point. So now, go back to our graph. When we had negative 2, and I just realized I wrote this first ordered pair wrong. That's a negative 2, 3, not a positive 2, 3. When I graph this first one, I see that negative 2, 3, That's the same point that I did before, and we want to include that one. So that tells us that this one should actually be solid. We're only counting it on the red function, not the purple function, because remember, we can't include it in both pieces, but it is possible that we don't end up having an open circle there. So that's the 1. Then we have -1, 2. And then we have 0, 3. 0, 3. This is going to be a parabola. I know that because it's an x squared. If you're not sure what this should look like at this point, go ahead and do one more. Do x is equal to 1, and you would find out that you would get this point right here. That's because this is going to be a curve that looks like a parabola. It's a U-shaped graph. So that is our entire graph. Then it goes on and it wants to know, part B is to, or number 2 is to state the domain and range. So the domain, looking at our arrows left and right, I have arrows at the left and arrows to the right, so that would be all real numbers. That means I go from -infinity to +infinity. Then our range, again, if I look at the arrows, I have arrows that point up and arrows that point down, and there's no holes in the middle. Everything in the middle has been covered, so that's also going to be -infinity to +infinity. Okay. And then the last part of this is to evaluate these values, which we have practiced this a little bit now. So I'm going to do this up in this blank space at the top. If I want to do f of 3, that means that I need to take +3 and plug it in for x in the case that makes the most sense. I'm trying to decide if it's less than -2 or greater than or equal to. 3 is greater than or equal to -2, so that's how we know that we are going to use the bottom equation and do the quadratic. So I get 9 plus 6 plus 3, which is 18. So f of 3 is 18. F of -4, that's a value that is less than 2, so we know that we're going to use the top equation. F of -4 would be -4 plus 5, which is 1. So that's our answer for f of -4. And then f of -2, they both have a -2. The way I decide which one it is the bottom one says I can be equal to -2. The top equation does not. So we would have to plug that into the quadratic. Now, we've already actually done that twice if you look over at our work in the purple and the red. So we already know what f of -2 is because we've already plugged it in. F of -2 is going to give us +3. And so that would be our answers for each of those. Let's look at another example. Okay, I want to graph this function. Now, there's another reason that this one is different than the ones we've looked at before, and that's, hold on, go away. Let me put this back. It's doing weird things. Hang on. Here we go. Okay, the other reason why this one is different is because you'll notice this has 3 different pieces to it. Everything we've looked at before had just 2. That's not going to change the way we do this any. We're just going to look at 3 different instances. Okay? I'm going to write a little bit smaller on this one so I can try to fit a bunch of stuff in here. So I'm going to look first at the top equation, which is x squared plus 2 when x is less than or equal to 0. So first I'm going to plug in 0. If I plug in 0, I get 0 squared plus 2, which is 0 plus 2 2. So that means that my first ordered pair is 0, 2. Let's pick another one that is less than or equal to 0. So let's try negative 1. Let's do negative 1 squared plus 2. That's going to be 1 plus 2, which is 3. So negative 1, 3. And let's do one more. Let's do negative 2 squared plus 2, which is 4 plus 2, so I get 6. That means when I plug in negative 2, I get out 6. So let's look at this piece on the graph. Less than or equal to 0 means I'm going to include it. So we are going to put a solid circle at our first point, which was 0, 2. Then we have negative 1, 3. And we have negative 2, 6. Now you can kind of see we've gotten half of a parabola here. So we're going to have half of this U-shaped curve. That's the kind of graph that we're going to get right there. All right, let's look then at the next piece, which is 2x minus 1. Now, again, I'm working on this table method here to try and help out if we're missing any sort of pieces to this puzzle. But if you see that and can determine what that line is supposed to look like, go ahead and graph it using slope-intercept form, if that is fine with you. Now, here's what is different about this one. We have a range. X is between 0 and 4, not including 0, including 4, based on our inequalities. So what I would do is plug in those two values. Plug in 0 and plug in 4. That's going to show you where your line starts and where your line stops. So we could just connect those 2 points. So I'm going to do 2 times 0 minus 1, which is going to be negative 1. So that point would be 0, negative 1. Then I'm going to plug in 4 because that was my other endpoint. 2 times 4 minus 1, 8 minus 4 would be 7. So 4, 7 is the other one. Open circle at 0. So 0, negative 1 would be here. Closed circle at 4, 7. Now the next interval of this graph, that means is going to be right here. Last thing is a constant function, and it says when x is greater than 4, it's always going to be a y value of 3. We're not including the 4, so at 4, 3, we're going to have an open circle, and then it is a constant function for all the values greater than. So your piecewise function would look like this. Really bizarre, but that's what it's going to look like. All right, so now it wants to know domain and range. So here's what we need to look at. Let's look at the domain first. I have an arrow that goes this way to the left, and I have an arrow, to the right, and I have an arrow that goes to the left. So I know that everything from here on is going to be included, and everything from here on is going to be included. The question is this blank space in the middle. So here's where I'm going to look at. I'm going to draw a bunch on this graph. I hope it doesn't confuse you more. Where I'm not sure is right here. All the space in between. And then we also want to look at this value here. The purple and the red, I have an open circle at this side, but if you look up, I have a closed circle that corresponds with that, so that means that point x is equal to 0 is included in our domain, so we want to have that. All this red line here means that we are including all this in-between space. The question now is at the value x is equal to 4. If we go up, we see an open circle here, so that means not to include it. But if we keep going up, we end up counting it. So that means that really every single x value from left to right is going to be included. That will tell us that our domain It's my dog making noises in the background. So for number 2, the domain would be negative infinity to positive infinity. My infinity signs look like glasses. They're kind of weird. And then the range is similarly, we're going to look at the y's. Now let me see if I can kind of erase some of this without taking away the graph too much. So you don't get confused with all of this. Okay. Sort of. Okay. Good enough. What we want to look at now is up and down. Now, I do have an arrow that looks up. I definitely have that. This arrow keeps going up. So I know that I'm going to keep going up to positive infinity. So we can go ahead and put that one in here. Positive infinity is where we know that we're going to go. The question is, where does the range start? The lowest value it ever gets to is right here. That is a value of -1. And that was, even though I kind of erased it, that was an open circle. So we want to use parentheses and not brackets. We're going to go from -1 to positive infinity. And again, if you're concerned about this open circle here, just look across. Here it was an open circle, but we got that point right here, so it ended up being included. Then to evaluate those points, we would go ahead and plug them in. F of -4, that would go into the top equation, less than or equal to 0. F of 8 would go into the bottom equation, which really you would just still get 3 because there is no equation. It's going to always stay 3. And then F of 2 would fall into that between 0 and 4 range, so that would go into the middle equation. That's how you would determine your values. Okay? All right, moving on. I want to look at a couple examples of applications here where we will have piecewise functions described to us. This is a scenario that some of you guys might be familiar with. So you have a summer job that pays an hourly rate of $7 per hour. If you work more than 40 hours in a week, you make time and a half for each hour of overtime, meaning you get paid 1.5 of your hourly rate. So the first question is, how much do you make if you work 32 hours in a week? 32 hours is not overtime. So we can assume that we're only going to be making our $7 an hour rate because we've fallen in that 40 hours or less category. So we would take our $7, multiply that by 32, and that's going to be $224, I think. I don't have my calculator on me. I should have brought that. $224. Okay. Question B says, how much do you make if you work 47 hours in a week? Well, we got to think about how this would break down. The first thing that I'm going to do is I'm going to make $7 for the 40 hours that I worked that were not overtime. But then I'm going to add to that time and a half would come out to be $10.50. Half of 7 is $3.50, so altogether I get $10.50 times the 7 extra hours that I worked. Okay, so again, the first quantity there is my normal hourly rate times the 40 hours of normal time that I worked, plus the second quantity, which is $10.50, that's my overtime rate, times only 7, because 7 is the only amount of overtime that I worked. The other 40 hours were just normal. So this is 280 plus, oh golly, $33.50 maybe? No, that's way wrong. 7 times 10 would be 70. 7 times 0.5 would be 3.5. 73.50, I think. If that's wrong, make a comment. You can edit it later. And so if we add those together, we get $353.50. This is obviously before taxes. Okay. Now, one thing that you are going to notice is a lot of times when they give you these problems, they give you these parts A and B to kind of get you thinking about how you would set up the problem, writing the piecewise functions. Could you have calculated this without setting up this expression? Absolutely, but this expression is really going to help you to determine what your equation is going to be. So it's going to be a good habit for you to kind of think about in a concrete sense what it is that you need to do. Okay? So we want to write a piecewise function, and they've kind of given us some rules about what we're supposed to call stuff. So we want to write our paycheck P in terms of the number of hours worked. To write this using function notation, whoops, I'm using a highlighter, we would say that we want P of H. That means we want the value for the number of hours gives us the paycheck. So P of H is equal to, now we're going to set up our piecewise function. If H is the number of hours that we've worked, then the first equation, I hope it makes sense to you, should be 7 times H. We get $7 times the number of hours that we worked. Now the second one is a little bit trickier, and I'm going to show you kind of off to the side here how I came up with this one. Let me switch colors. So I know that I get paid $7 for the number of hours I worked. But if you go back to example B, you'll notice that in that example, if I just used H, H would be 47. But nowhere in that expression did we plug in the number 47. We did 40, and then we got 7 for the second time because that was 47, take away the 40 hours that were not overtime. So we could think about this is I'm going to have 7 times 40. We're not going to use H this time because we know how many hours of regular time we had to have worked to get to overtime. That's no longer an unknown. Then we're going to say plus $10.50, I'm just going to say 10.5, times, I cannot put H because H would mean my overtime hours and my regular hours. So I would need to take the number of hours I worked and subtract 40 from it. I have to take off the regular time hours. And then to simplify this, we can just multiply and distribute. So we get, let's see, 10.5 H. Here I go with mental math again. Let's see. 10 times 40 is 400 plus 200, 600? That seems wrong. 10.5 times 4, 22,024. Decimal place one way. Except I'm going to have another 0 on there. $420. I was way off. Ignore that. $420. Then we could combine our like terms here, which would give us 10.5H minus 140. And so that's going to be the second one. 10.5, or you can write 50 if you want to think dollars and cents. 10.50H minus 140. Now don't forget, we have our two equations, but we still need to be able to write what those intervals are. If you work 40 hours or less, that's when you make $7 an hour. So that's going to include 40. That would be for H values that are less than or equal to 40 hours. The second one would be for H values that are greater than 40 hours. And again, we don't want to include 40 this time because for two reasons. One, we've already included it in the previous interval and you can't include it twice. But secondly, because the second you step over 40 hours, that's when you're making more money. If you work exactly 40, you're not technically getting overtime yet. Okay? All right, and then it would have you graph it, which I'm not going to do right now because we just did two examples of graphing. You can look back at those, how you would want to do that. In this case, you can't see all of my graph here, but you can see it's not labeled. So something like this where you have to go to a value that's possibly negative 140 or something like that, just make sure that you label your axes because you're probably going to have to pick a scale other than counting by ones. So just label that clearly. I just want to show you one more example of a word problem before we finish up here. And again, if you feel like you have the idea, feel free to stop this video and you can come back to it later if you need to. You can start working on stuff. But here's the last example. The weekend rates for a parking garage are pictured. So for this garage, you pay $3 per half an hour, no matter what. So 1/2 an hour or 15 minutes, you're going to pay $3. Then you pay more for each half an hour. However, there is an $8 maximum. So once you get to a point where it's $8, then no matter what, you're going to pay $8. So again, these questions are kind of meant to get us thinking about what this equation is going to look like. So the first question is, how much would you pay if you parked for 15 minutes? Well, you have to pay $3 for that first half an hour. So it doesn't matter that it was 1 minute, 2 minutes, 15 minutes, 29 minutes. You are going to pay $3 because that's what it costs up to that first half an hour mark. How much would we pay for 1 hour? We'd pay $3 for the first half an hour, $3 for another half an hour. I wrote 30 again instead of 3. And so that would give us a total of $6. Then we want to know how much we would pay for 5 hours. Well, 5 hours would be, I hope you all agree, that would be 10 half hours. If we multiply that by the half-hourly rate, that would be $30. That exceeds our maximum of what we're going to pay, so we would only have to pay $8 because that's the most that they're ever going to ask us to pay. So for D, it wants us to write and graph a piecewise function that represents the cost of parking P in terms of the number of hours parked H. One thing that's really important to notice here, they want a function that is measured in hours, not half hours. So the first half an hour would be 0.5 of an hour. We need to make sure that we pay attention to that. I'm going to write my function up here where I have a little bit of space. So P of H, cost of parking per hour, is going to be, this one's going to have 3 different cases. Up to the first half an hour, I'm going to pay $3. So that would be values of H that are less than or equal to 0.5. As long as my time is a half an hour or less, I only have to pay that initial $3. Then, let's think about what happens. $3 for half an hour, $6 for a whole hour, $9 for an hour and a half. So we've already exceeded that $8. So that means that the only possible price, just ignore my dog, the only possible price that we could pay without going over the maximum would be $6. There's no way that I would pay less than that or more than that. If I did only 1/2 an hour, I would have to pay $3. If I do a whole hour, I would have to pay $6. If I did more than a whole hour, if I went up another half an hour, that would take me to 9, which is too much. I'm not ever going to have to pay $9. So, hold on. Okay, so that's why we know that it's 6. And that's going to be for H values that are between 0.5 and 1. Between half an hour, and that would actually include 1, because 1 hour would be the $6 price. As soon as I exceed 1 hour, anything over 1 hour is going to cost me $8. So that's for all values of H that are greater than 1. Super weird kind of idea. But again, those parts A through C is really to kind of walk you through to see what that would look like. Now, this graph, I'm not going to go down onto the graphs, and I'm not going to graph it super accurately, but I want you to have an idea of what that would look like. We would have 3, 6, and let's call this one 9 just to keep our units consistent. And let's say here's 0.5, here's 1, 1.5, 2 hours. It would look like this. Let me switch colors so we can see it. Okay. I would not want to include 0. And I guess technically that would make more sense for us to go up here and say that H's that are between 0 and 0.5, because if you parked 0 hours, then you shouldn't pay anything, because that means you didn't park at all. So we would have an open circle here, and that would go up to and including a half an hour. That's a constant section, so it would be a flat line. Then we go up to 6. We wouldn't include this here, but that would go constant function up to 1. Then we would go up to 8, which is going to be a little bit in between, and that would be for any values that are greater than that. And this is an example of what we call a step function. It goes from flat, constant increments up a little bit at a time. So you see, it's almost like they're trading values from one to the other. When I get to here, I bounce up to this open circle. When I get to the next one, I bounce up to the next open circle. That's why it's called a step function, because you can see this sort of stair-step pattern that it follows. So that's just a little bit of new vocabulary for you. Okay, so you have a packet, hopefully, that you got from the sub, and you do not need to do the whole thing. Make sure you check on Blackboard to see which problems it is that you're supposed to do. Right? See you back soon.